咁第29條咧就係 data analysis 嘅題目啦。咁我哋咧就要睇翻啦，喺唔同嘅生長素濃度底下，咁究竟一個發緊芽嘅種子佢嗰個根嘅平均長度會有咩變化咧？咁啊 x-axis 就係生長素嘅濃度啦，咁啊由0開始去到好高好高啦。咁啊 y-axis 咧就係根嘅長度嚟嘅。咁題目就問我哋啦，睇完幅圖咧有咩嘅推論可以得到出嚟？咁呢一隻題目咧同我哋之前嗰啲 draw conclusion 係一模一樣嘅。咁所以記緊啦。得出嘅咧係一個直接嘅結論，而唔係咧一啲由書本上面學到嘅知識嚟嘅。我哋做一擊破咯喎。A 咧佢就話啦，生長素咧係能夠令到個根咧係生長咗嘅。嗱呢一句咧本身係喺書本都有學過翻嚟嘅。生長素咁梗係幫個根去成長㗎啦。但係睇翻幅圖啦，又係咪絕對係咁嘅情況咧？咁我哋咧去理解下嘅就係當冇加到 auxin 落去嘅時候咧，咁其實棵植物咧佢自己都有一個基本嘅生長素噶嘛，咁所以啦棵植物咧原來啦都能夠生長到咧0.8 cm 咁長嘅。咁若果啦我哋不斷咁將個生長素嘅濃度增加、再增加、再增加，咁我哋發現咧頭段咧佢的確咧都仲係生長緊嘅，直至到過咗藍色呢條線啦，就係咧呢一條線。咁我哋會發現啦，咦原來咧佢嗰個生長咧係渣過0.8 cm 嘅喎，咁即係話啦，過咗藍色線呢一個濃度之後咧，其實嗰個根嘅成長係慢過平時嘅，咁所以應該咧太高濃度嘅時候咧，對個根嚟計咧係一個抑制嘅作用，咁即係話呢一句咧就不盡不實啦，佢前面係啱㗎，但係後面係錯，所以咧成句都係錯。好，跟住 B 同 C 咧，我想一齊講，因為咧佢哋都嘗試去解釋翻咧而家我哋呢幅圖所見到嘅現象嘅。咁啊 option B 咧，佢本身咧自己係錯嘅，因為啦 auxin 咧根本就唔會去 promote 一個 cell division， 相反啊，佢係只係令到啲 cell 咧透過吸水去令到佢變大嘅啫。咁即係本身 B 呢句啦，但係佢本質已經錯，咁所以更加冇可能喺幅圖度得出嘅結果啦。咁你話 C 咁咪啱咯，梁 Sir。嗱，你頭先講噶嘛，透過咧生長素令到啲細胞咧就吸水，從而令佢變大嘛。咁 C 咪就係講呢句咯，生長素令到咧啲細胞咧就吸水，然後咧就導致到佢咧變成長咗嘅。咁但係啦，呢一句雖然係啱啫，但係你喺幅圖度係睇唔出呢個咁樣嘅結果噶嘛。咁即係話咧 C 呢句咧都係錯，咁所以答案咧就係 D 啦。喺唔同嘅auxin濃度底下，我哋的確係見得到唔同程度嘅根嘅延長啊，係嘛？喺初頭咧由0不斷增加嘅時候咧，佢的確係比起正常情況係長一啲嘅喎，再生得快一啲喎。但係啦，當嗰個 auxin嘅濃度繼續增加嘅時候咧，原來啦佢就有一個抑制嘅作用啦。咁所以答案咧就係 D 啦。In question 29, we have to do the data analysis of the graph. So the graph is showing the average root length of the germinating seed irrigate with the different auxin concentration. So you can see that in the x-axis, that's the auxin concentration from 0 to higher and higher. And for the y-axis, that's the root length in cm. And this question is asking for the options A, B, C, D, which of the following can be deduced from the above graphs. It's asking us to draw the direct conclusion from the observation instead of the biological knowledge from the book. This type of question, we did it before. So remember, we observe the result and then draw the conclusion. We do not need to think too much. So let's take a look at the answer one by one. For the option A, auxin promotes the elongation of the root. This concept, that's something we learned from the book. So let's see, can it be drawn from the graph? Auxin promotes the elongation of the root. So let's see in the 0 concentration of auxin. So we can see that the root, it has its normal growth, the natural growth. So it is 0.8 cm. So when we are increasing the auxin concentration, we can really see that the root can really grow longer than the 0.8 cm. So it seems like that auxin has a promotion effect. However, after the auxin concentration past the blue line, this concentration, so we can see that the root growth is shorter than the normal growth. So that's why in this part, we can conclude that it seems like to be an inhibitory effect rather than the promotion. So that's why option A is not correct at any time because beyond a certain concentration of auxin, there will be an inhibitory effect on the root growth. So that's why option A is wrong. And then I would like to talk about option B and C at the same time because they are the proposed explanation for this phenomenon observed from the graph. So for option B is wrong itself because for the auxin, it cannot promote the cell division. Its true function is exert the effect on the region of elongation to promote the enlargement of the cell by water absorption. So that's why option B is wrong itself. So that's why we cannot draw this conclusion from the graph as well. And for option C, you may say that, oh, option C is correct, Mr. Leung. Auxin promotes water absorption. That's what you say. But the point is that this is the knowledge from the book. But this detailed mechanism cannot be concluded from the graph. We cannot deduce this concept from the graph only. So that's why option C is not correct. So that's why the answer is D. Different concentration of auxin results in difference in the extent of the root elongation. So that's something we can really see from the graph. From the 0 concentration to the blue line, we can see that there is really a stimulation or promotion effect to the root growth. But beyond the blue line, at a certain concentration, the effect will become inhibitory. So that's why different concentration of auxin will lead to a different extent of the root elongation.